Stephen William Hawking was born on January 8, 1942, in Oxford, England, coinciding with the 300th death anniversary of Galileo Galilei. His parents, Frank and Isabel Hawking, valued education deeply despite modest financial means. Frank worked as a medical researcher, while Isabel served as a secretary. World War II forced his mother to move to Oxford for safety during his birth. Hawking grew up in a household that encouraged curiosity, discussion, and intellectual exploration, shaping his early mindset toward science and discovery. Hawking's family relocated to St Albans, a small city north of London, where Stephen spent most of his childhood. The Hawking home was filled with books, scientific journals, and constant debates on diverse topics. Despite the intellectually rich environment, Stephen's school performance in early years was unremarkable. His classmates nicknamed him Einstein because of his inquisitive nature and his talent for building complex mechanical devices from scraps. He developed a fascination with the stars, driven by nights spent gazing at the sky through homemade telescopes. Stephen attended St Albans School, where his talents gradually became evident. He excelled in mathematics and physics, displaying an extraordinary ability to visualize problems in his head. However, his unconventional learning style sometimes clashed with traditional teaching methods. Outside academics, Hawking enjoyed constructing model airplanes and experimenting with clock mechanisms. His father hoped Stephen would study medicine, but Stephen's interest leaned toward mathematics, inspired by the beauty of logical structures and the mysteries of the universe. This passion would guide his academic journey and future research directions. In his teenage years, Hawking demonstrated exceptional problem-solving skills. While other students relied on paper calculations, Stephen often solved problems entirely in his head. His friends recalled his competitive spirit, especially in intellectual games and debates. Although not particularly athletic, Hawking enjoyed rowing, which would later play an important role in his social life at university. By the time he finished school, his academic strengths were undeniable, and his teachers encouraged him to apply to Oxford University, one of the world's most prestigious educational institutions. In 1959, at the age of 17, Hawking began his studies at University College, Oxford. Initially, he found the coursework surprisingly easy and admitted that he spent only about an hour a day on academic work. This gave him time to join the rowing team as a coxswain, where his leadership skills flourished. Hawking's sharp wit and sense of humor made him popular among his peers. Despite his relaxed approach, he graduated with first-class honors in physics, setting the stage for his postgraduate research career. After Oxford, Hawking moved to Cambridge to pursue a PhD in cosmology at Trinity Hall. He chose cosmology because, as he once said, it seemed there were no good experimentalists, so it had to be a good subject. Under the supervision of Dennis Sciama, he explored the origins of the universe, black holes, and the nature of spacetime. However, his early Cambridge days were overshadowed by troubling symptoms, frequent clumsiness, difficulty speaking clearly, and a general loss of coordination, which prompted medical investigations. In 1963, at age 21, Hawking was diagnosed with amyotrophic lateral sclerosis, ALS, also known as motor neuron disease. Doctors predicted he might have only 2 years to live. This devastating news initially caused a deep depression. However, meeting Jane Wilde, an undergraduate student in languages, provided emotional support and renewed determination. Jane's optimism inspired Hawking to focus on his research and live as fully as possible. Their relationship would later lead to marriage, marking an important turning point in Hawking's personal and professional life. Hawking's illness progressed slowly, allowing him to continue his studies despite physical limitations. He began using crutches and required assistance with certain tasks. His doctoral research centered on the implications of general relativity for the structure of the universe. He became particularly interested in singularities, points where gravitational forces become infinite, often linked to black holes. Collaborating with Roger Penrose, he developed groundbreaking theorems showing that singularities are an inevitable feature of Einstein's theory, suggesting the universe itself began with a singularity, the Big Bang. In 1965, Stephen married Jane Wilde. Their marriage brought stability and emotional strength during the early stages of his illness. Hawking completed his Ph.D. in 1966, presenting a thesis on the expansion of the universe. His work attracted considerable attention, and he was appointed a research fellow at Gonville and Caius College, Cambridge. Despite his worsening condition, he traveled, lectured, and attended conferences. His ability to visualize complex physical phenomena without writing extensive equations became one of his most remarkable intellectual strengths. Hawking's collaboration with Roger Penrose in the late 1960s revolutionized the understanding of black holes. They demonstrated that black holes are not entirely static but can change over time due to general relativity's predictions. These insights led Hawking to consider quantum effects in black holes. His curiosity about how black holes might behave at the quantum level would soon lead to one of his most famous contributions, the theoretical prediction that black holes emit radiation, a phenomenon now known as Hawking radiation. By the early 1970s, Hawking's health had deteriorated further, making speech increasingly difficult. Nevertheless, his intellectual output grew. In 1974, he shocked the scientific community by proposing that black holes could emit thermal radiation due to quantum effects near their event horizons. This radiation meant black holes could eventually evaporate completely, a radical idea challenging the notion that nothing could escape them. The discovery linked quantum mechanics, general relativity, and thermodynamics, marking a major step toward a unified theory of fundamental physics. Hawking's discovery of black hole radiation earned him worldwide recognition. In 1974, he was elected a Fellow of the Royal Society at just 32 years old. The following year, he was appointed Lucasian Professor of Mathematics at Cambridge, a position once held by Isaac Newton. Despite severe physical limitations, Hawking continued producing influential research papers. He began using a wheelchair full-time, but his mind remained exceptionally active. His lectures drew large audiences, as people were eager to hear from the brilliant scientist defying medical expectations. As his condition advanced, Hawking lost the ability to write by hand and relied on assistants for note-taking. In 1985, a tracheotomy to treat pneumonia resulted in the loss of his natural speech. He began communicating through a speech-generating device, initially operated by hand and later by cheek muscle movements. This computer system, developed by engineers, became an iconic part of his public persona. Despite these challenges, Hawking maintained a demanding schedule of research, teaching, and public appearances, inspiring millions around the world. In 1988, Hawking published A Brief History of Time, a popular science book explaining cosmology to general audiences. The book tackled concepts like the Big Bang, black holes, and the nature of time in accessible language. It became a global bestseller, selling over 25 million copies and translated into dozens of languages. While some readers found it challenging, its success cemented Hawking's reputation as both a pioneering scientist and a gifted communicator. His fame reached beyond academia, making him a household name. The success of A Brief History of Time opened doors for Hawking to engage with the public on an unprecedented scale. He appeared on television shows, participated in documentaries, and gave public lectures worldwide. His ability to blend humor with profound scientific insight made him a unique cultural icon. Despite his physical condition, he traveled extensively, promoting science education and advocating for greater curiosity about the universe. By the early 1990s, Hawking was both a scientific legend and a beloved figure in popular culture. In the early 1990s, Hawking continued advancing theoretical physics, focusing on unifying general relativity and quantum mechanics. He explored the no-boundary proposal, developed with James Hartle, which suggested that the universe had no temporal boundaries before the Big Bang. This model implied that time behaved like a spatial dimension at the universe's origin. The concept challenged traditional ideas about cosmic beginnings. Hawking's bold theories, though controversial, sparked significant debate and inspired new research directions in cosmology, quantum gravity, and the origins of time itself. Hawking's personal life during the 1990s was complex. His marriage to Jane Wilde faced increasing strain due to the pressures of his illness, his growing fame, and the presence of full-time caregivers. Jane's dedication had been unwavering for decades, but the emotional and physical demands became overwhelming. In 1995, the couple divorced amicably. That same year, Hawking married Elaine Mason, one of his nurses. While the marriage was initially supportive, it later attracted public attention due to rumors of emotional and physical difficulties. Despite personal challenges, Hawking's professional influence remained undiminished. He published Black Holes and Baby Universes and Other Essays in 1993, a collection blending scientific essays and autobiographical reflections. The book revealed more of his personality, sense of humor, and philosophical musings. Hawking also took on more public roles, advocating for space exploration and warning about potential existential risks to humanity. He expressed concerns about nuclear war, climate change, and the possible dangers of artificial intelligence, issues that would feature increasingly in his later public statements. In 2001, Hawking released The Universe in a Nutshell, a lavishly illustrated follow-up to A Brief History of Time. This work aimed to clarify some of the more difficult concepts from his earlier book, including superstring theory, the shape of the universe, and the possibility of parallel universes. The combination of accessible language and high-quality visuals made it popular among general readers. By this time, Hawking was one of the most recognized scientists alive, his image synonymous with intellectual brilliance and perseverance. During the 2000s, Hawking embraced opportunities to inspire younger generations. He appeared in popular television series such as Star Trek, The Next Generation and The Simpsons, often portraying himself humorously. These appearances helped humanize his public image, showing that even a world-class physicist could have fun with pop culture. He also collaborated with his daughter, Lucy Hawking, on a series of children's books introducing science in engaging ways. Through these efforts, he encouraged curiosity and made complex ideas more approachable for young minds. Hawking's health required increasing medical support, but technology allowed him to maintain independence. His speech-generating device was upgraded with advanced software that could predict words and phrases, enabling faster communication. He continued traveling to lecture halls, research conferences, and public events worldwide. His speeches often combined profound scientific ideas with witty remarks, captivating audiences regardless of their scientific background. Hawking's unwavering commitment to public engagement demonstrated his belief that science should be shared, not confined to academic circles or specialist communities. In 2007, Hawking took part in a zero-gravity flight aboard a modified Boeing 727, experiencing weightlessness for the first time. This event symbolized his adventurous spirit and his determination to challenge limits. Although his doctors had concerns, Hawking insisted on participating, describing the experience as amazing. The flight, widely covered by international media, highlighted his message that physical limitations should not constrain dreams. It also reinforced his advocacy for human space exploration as a means to ensure the long-term survival of humanity. Throughout his career, Hawking remained committed to tackling profound questions about the universe's fate. He explored concepts like the multiverse, cosmic inflation, and the nature of black hole information loss. His information paradox sparked decades of debate among physicists, eventually leading to important developments in theoretical physics. Even when his ideas were challenged, Hawking welcomed the process of rigorous scientific argument. His resilience in defending bold hypotheses demonstrated his conviction that challenging established views was essential to advancing scientific understanding. In 2010, Hawking co-authored The Grand Design with physicist Leonard Mlodinow. The book argued that the laws of physics alone could account for the creation of the universe, without the necessity of invoking a divine creator. This sparked considerable controversy among religious groups while gaining praise from many scientists. The work introduced M-theory as a candidate for a unified theory of everything. Hawking's willingness to address philosophical implications of science reinforced his status as both a thinker and a provocateur. Hawking's second marriage ended in 2006, and in the years following, he appeared to reconnect more closely with his children from his first marriage. He continued working at Cambridge until his official retirement from the Lucasian professorship in 2009. However, retirement did not slow his pace. He maintained a heavy schedule of writing, lectures, and media appearances. His later works increasingly focused on humanity's future, advocating for space colonization, renewable energy, and international cooperation to address global challenges threatening human survival. Hawking's life inspired numerous documentaries and films, culminating in the 2014 biographical drama The Theory of Everything. The film, based on Jane Hawking's memoir Traveling to Infinity, portrayed their relationship and Stephen's early career. Eddie Redmayne's portrayal of Hawking earned critical acclaim and an Academy Award. Hawking himself praised the film, remarking on its emotional impact. The movie introduced Hawking's story to millions who were unfamiliar with his scientific work, further cementing his place as one of the most iconic figures of modern science. In his later years, Hawking became increasingly outspoken about pressing global issues. He warned that unchecked climate change could devastate Earth's ecosystems, rendering large areas uninhabitable. He also expressed concerns that artificial intelligence, if not properly regulated, could surpass human capabilities and pose significant risks. Despite these warnings, Hawking remained fundamentally optimistic about human ingenuity. He believed that through science, collaboration, and determination, humanity could overcome challenges and create a better future, both on Earth and potentially on other worlds. Hawking's final years were marked by ongoing health struggles, yet he remained intellectually active. He continued publishing scientific papers, participating in conferences remotely, and mentoring younger scientists. His collaborations spanned the globe, facilitated by digital communication tools. Hawking's persistence served as a powerful example for students and colleagues alike. He demonstrated that physical disability need not limit one's intellectual contributions, and his career became a testament to the power of the human mind to transcend even the most severe physical challenges. On March 14, 2018, Stephen Hawking passed away peacefully at his home in Cambridge, aged 76. The date was notable, coinciding with Albert Einstein's birthday and Pi Day. Tributes poured in from around the world, from fellow scientists, political leaders, celebrities, and ordinary admirers. Many highlighted his contributions to science, his courage in facing illness, and his ability to inspire millions. His passing marked the end of an extraordinary life, but his ideas and influence continue to shape modern cosmology and public understanding of science. Hawking's ashes were interred at Westminster Abbey, between the graves of Isaac Newton and Charles Darwin, an honor reserved for Britain's greatest scientists. The ceremony celebrated both his scientific legacy and his human story of resilience and determination. A memorial speech by astronaut Tim Peake emphasized Hawking's lifelong curiosity and his advocacy for space exploration. As a symbolic gesture, a message from Hawking, accompanied by music, was beamed toward a black hole, reflecting his lifelong fascination with the mysteries of the cosmos. After his passing, Hawking's influence extended beyond physics. Universities established scholarships and research programs in his name, aimed at encouraging future scientists to explore cosmology and theoretical physics. His books remained bestsellers, continuing to inspire readers worldwide. Documentaries and interviews were replayed, ensuring his voice still reached audiences. Social media tributes emphasized how Hawking broke barriers, proving that severe disability need not limit intellectual achievement. He became a lasting symbol of perseverance, curiosity, and the human drive to understand the deepest mysteries of existence. Hawking's academic legacy rests on several groundbreaking contributions. His singularity theorems with Roger Penrose reshaped our understanding of general relativity, proving that space-time must contain singularities under certain conditions. His theoretical prediction of Hawking radiation bridged quantum mechanics and relativity, influencing decades of black hole research. These achievements represented not only deep mathematical insight but also conceptual courage, as they challenged established views. By addressing questions about the universe's origin and ultimate fate, Hawking helped lay the foundation for future work in quantum gravity. His work on the no boundary proposal with James Hartle offered a new perspective on the universe's beginnings. The idea suggested that time could behave like a spatial dimension at the earliest moments, eliminating the need for a defined starting point. While not universally accepted, it inspired extensive discussion and research in cosmology. Hawking thrived on such intellectual challenges, welcoming debates that tested his theories. His willingness to engage with competing ideas demonstrated his belief that scientific progress depends on open-minded, rigorous inquiry and constant questioning. Beyond science, Hawking's life was a triumph over adversity. Diagnosed with ALS at 21, he defied all medical expectations by living more than 5 decades beyond his prognosis. His deteriorating physical abilities did not diminish his productivity. Instead, they sharpened his focus on the most profound questions. Hawking's ability to continue teaching, writing, and conducting research while entirely dependent on assistive technology remains unparalleled. He demonstrated that intellectual contributions need not be limited by physical condition, inspiring countless people facing challenges worldwide. Hawking's personality combined brilliance with humor. He often used wit to disarm audiences and make complex ideas more relatable. Famous for playful remarks, he once quipped that, "Life would be tragic if it weren't funny." He even placed friendly bets with other physicists about unresolved scientific problems, such as the black hole information paradox. These bets were lighthearted but underscored his openness to being proven wrong, a quality rare among prominent scientists. Hawking's humor made him approachable and helped bridge the gap between science and the public. His appearances in popular culture broadened his reach beyond academia. Cameos in The Simpsons, Futurama, and The Big Bang Theory introduced him to audiences who might never read a physics paper. In each appearance, he playfully embraced his public persona, often making jokes at his own expense. These moments showed that he did not take fame too seriously and was willing to use it to spark interest in science. This combination of intellect, humility, and humor made Hawking a beloved global figure. Hawking's views on the future of humanity were both cautionary and hopeful. He warned about existential risks such as climate change, nuclear weapons, and unregulated artificial intelligence. At the same time, he promoted the idea that humanity could secure its survival by becoming a multi-planetary species. He argued that colonizing other planets would safeguard civilization against disasters on Earth. His advocacy for space exploration was rooted in both scientific curiosity and a practical vision for the long-term survival of our species. In his later writings, Hawking addressed profound philosophical questions. He argued that the universe could be explained entirely by the laws of physics, without requiring supernatural explanations. This perspective was controversial among religious communities but consistent with his commitment to scientific reasoning. He maintained that science and religion were fundamentally different in method and purpose, and that scientific inquiry should guide humanity's understanding of the cosmos. His willingness to address such topics reflected his role not just as a scientist, but as a public intellectual. Hawking also dedicated time to education and outreach for people with disabilities. He championed accessibility in academia, advocating for adaptive technologies and support systems that could enable others to pursue careers despite physical limitations. His own life was a testament to the power of such tools. He credited his speech-generating computer and dedicated team of caregivers for enabling his continued productivity. By sharing his story openly, Hawking inspired advancements in assistive technology that have since benefited countless individuals worldwide. His daughter Lucy Hawking recalled that her father approached parenting with the same curiosity and humor he applied to science. Together, they authored children's books such as George's Secret Key to the Universe, blending storytelling with real scientific concepts. These works introduced young readers to astronomy, black holes, and planetary science in an engaging way. Hawking viewed education as a lifelong process and believed that sparking curiosity in childhood was essential for nurturing future scientists and problem solvers who could tackle humanity's biggest challenges. Hawking's relationship with the public was unusually direct for a scientist of his stature. He answered questions from schoolchildren, participated in televised Q&A sessions, and even engaged with fans online. He understood that public interest in science was a fragile but valuable resource. By making himself available, he encouraged a culture where scientists were not distant, inaccessible figures, but active participants in society's intellectual life. His approach helped bridge the gap between cutting-edge research and everyday understanding, a legacy still felt today. He often reflected on the meaning of life and humanity's place in the universe. While he acknowledged that the vastness of space might make human life seem insignificant, he emphasized that our ability to understand and shape the future gave life profound value. Hawking's message was one of empowerment. Even in a universe governed by impersonal laws, human creativity and resilience mattered. This outlook resonated deeply with audiences, who found in his words a reminder that knowledge itself could be a source of purpose. Hawking's honors and awards were numerous. He received the Copley Medal, the Albert Einstein Award, and the Presidential Medal of Freedom from the United States, among many others. While he never won the Nobel Prize, a fact often remarked upon, his influence on theoretical physics was undeniable. Nobel recognition requires experimental confirmation, and many of Hawking's most important ideas remain in the realm of theory. Nonetheless, his peers recognized him as one of the most important scientific minds of the 20th and 21st centuries. Even in his final public appearances, Hawking remained committed to inspiring others. In 2017, he delivered a message to the Starmus Festival in Norway, urging young people to look up at the stars and not down at your feet. He encouraged them to be curious and to never give up, no matter the odds. This advice reflected his own life's journey, one defined by relentless curiosity, determination, and the refusal to let circumstances dictate the scope of his ambitions or his imagination. The enduring fascination with Stephen Hawking's life lies in its extraordinary combination of intellectual genius and personal resilience. His contributions to science fundamentally altered our understanding of black holes and the universe's origins. His ability to communicate complex ideas to a global audience transformed him into a cultural icon. Perhaps most importantly, his life story challenged assumptions about disability, demonstrating that the human mind can flourish even under extreme physical constraints. Hawking's legacy will continue to inspire generations to seek knowledge and persevere. Hawking's life also influenced policy discussions about science funding and accessibility. Lawmakers and educators frequently cited his achievements as proof of the value of investing in research and supporting people with disabilities. His career demonstrated that brilliant contributions could come from unexpected places if opportunities and resources were available. Hawking argued that science should be an international endeavor, free from political barriers, because understanding the universe benefits all of humanity. His advocacy underscored the importance of collaboration in tackling global scientific challenges. His public persona was shaped in part by the media's fascination with his condition, but Hawking often redirected attention to his work. He was careful to avoid being seen solely as a medical miracle, emphasizing that his real legacy lay in ideas. In interviews, he spoke candidly about his illness, but always in the context of how it motivated him to focus on meaningful pursuits. He hoped his example would encourage others to define themselves by achievements rather than limitations. Hawking's exploration of the black hole information paradox remains one of his most enduring scientific puzzles. The paradox arises from a conflict between quantum mechanics and general relativity. Information about matter falling into a black hole appears to be lost, violating fundamental physical laws. Over decades, Hawking revised his stance, ultimately suggesting that information might be preserved in subtle ways. This ongoing debate stimulated research across theoretical physics, inspiring creative approaches to reconciling the two great pillars of modern science. His theoretical work extended into speculative areas, such as the possibility of time travel. While acknowledging the immense challenges, Hawking explored the conditions under which closed time-like curves might exist. He even hosted a playful, time traveler's party, in 2009, sending invitations only after the event to see if anyone from the future attended. None did. This lighthearted experiment reflected both his willingness to engage with imaginative ideas and his knack for using humor to communicate complex scientific principles to the public. In addition to his research, Hawking placed great emphasis on teaching. Former students recalled his extraordinary ability to guide them through abstract problems using mental imagery rather than lengthy calculations. He encouraged originality, telling students that bold, unconventional ideas were worth pursuing, even if they risked being wrong. Many of his protégés went on to become leading figures in physics and cosmology. Through mentorship, Hawking's influence extended far beyond his own publications, shaping the next generation of scientific innovators. Hawking's approach to science was deeply visual. Unable to write equations easily, he relied on imagining physical systems in his mind's eye. This ability allowed him to manipulate concepts spatially, exploring possibilities before formalizing them mathematically. Colleagues noted that this skill gave him a unique perspective, often leading to insights others overlooked. His mental models became a defining aspect of his problem-solving style, proving that unconventional methods could yield groundbreaking discoveries. This visualization technique became an inspiration for scientists and educators alike. Despite his celebrity, Hawking lived a relatively modest life in Cambridge. His home was adapted for wheelchair access, and his office was filled with books, papers, and mementos from his travels. Visitors were struck by the contrast between his global fame and his down-to-earth manner. He enjoyed socializing with colleagues, hosting gatherings where discussions ranged from physics to music and art. Hawking believed that creativity in any field could inspire scientific thinking, and he cultivated friendships across a wide spectrum of disciplines. Hawking's optimism about human potential was tempered by realistic assessments of risk. He repeatedly warned about the dangers of ignoring scientific evidence on climate change, predicting that unchecked warming could trigger catastrophic events. He urged policymakers to act decisively, arguing that humanity's survival depended on respecting environmental limits. Hawking saw these issues not as separate from cosmology, but as part of a broader responsibility to ensure the long-term future of intelligent life, a perspective shaped by his deep appreciation for Earth's fragility. His collaborations were not limited to physics. Hawking worked with mathematicians, computer scientists, and even artists to explore new ways of visualizing and explaining complex concepts. One notable project involved holographic imagery to illustrate black hole theories. These interdisciplinary ventures reflected his belief that science could benefit from diverse perspectives and creative approaches. Hawking often said that the boundaries between disciplines were artificial, and that progress came from crossing them. His willingness to experiment with unconventional partnerships kept his work fresh and engaging. Hawking's public lectures often filled large auditoriums, with audiences captivated by both the content and the delivery. Using his computer-generated voice, he would weave together scientific explanation and personal anecdotes, often ending with a memorable, uplifting message. These talks inspired countless students to pursue careers in science. Many attendees described them as transformative experiences, changing the way they saw the universe and their place within it. For Hawking, these events were opportunities to share not just knowledge, but a passion for discovery. Although Hawking's speech synthesizer had a distinct, robotic tone, it became inseparable from his identity. He declined opportunities to upgrade to more natural-sounding voices, saying he had grown accustomed to the one he had used for decades. The voice became iconic, recognized worldwide and even imitated in media. It symbolized the fusion of human intellect and technology, a partnership that allowed him to communicate with millions. In many ways, the voice was as much a part of Hawking's legacy as his scientific work. Hawking's role as a cultural figure extended into humanitarian causes. He lent his name and voice to campaigns for disability rights, global health initiatives, and educational access in developing countries. He believed that intelligence and talent were distributed evenly across humanity, but opportunities were not. His advocacy highlighted the need for systemic change to allow more people to contribute to science and society. By connecting his personal story to larger issues, Hawking amplified important messages about equity and inclusion. His participation in the 2012 Paralympic Games opening ceremony in London was a particularly memorable moment. Addressing the crowd, he urged people to look at the stars and not down at your feet. His presence on such a global stage celebrated the achievements of athletes with disabilities and emphasized the limitless potential of human determination. The speech resonated deeply, reinforcing his role as both a scientific icon and a symbol of resilience. It remains one of the most replayed moments from the event. Hawking's collaborations with filmmakers and television producers resulted in a range of educational content. He appeared in BBC documentaries, hosted science specials, and consulted on visual effects to ensure accuracy. His ability to explain difficult ideas in clear, concise terms made him a sought-after voice in science communication. These projects introduced complex topics like quantum cosmology and gravitational waves to audiences who might otherwise find them inaccessible, helping to foster a greater appreciation for scientific inquiry across the general public. Even in the face of declining health, Hawking maintained a relentless schedule. His caregivers and assistants described his extraordinary discipline, spending long hours working through equations, reviewing papers, and preparing lectures. Travel required extensive logistical planning, yet he continued to visit conferences and events worldwide. Hawking saw each trip as an opportunity to exchange ideas and spark interest in science. His determination to remain active despite physical challenges reinforced his belief that intellectual engagement was essential to a fulfilling and purposeful life. Hawking's continued productivity relied on a close-knit team of assistants, nurses, and technical specialists. They helped manage his daily needs, maintain his equipment, and facilitate communication. He often acknowledged their contributions, emphasizing that his independence was a collective achievement. His relationship with his team reflected mutual respect and trust, and they were integral to his ability to function as an active researcher. Without such support, his extraordinary career would have been far more difficult, if not impossible, to sustain over decades. Despite his global fame, Hawking remained committed to the academic community in Cambridge. He regularly attended seminars, asked challenging questions, and encouraged young researchers to present their work. His presence in the department was a constant reminder that groundbreaking science could be pursued with creativity, collaboration, and determination. Colleagues valued his insights, often seeking his perspective on their projects. Hawking's intellectual curiosity was infectious, fostering a culture of exploration that continued to shape the department long after his official retirement. Hawking's fame sometimes overshadowed the complexity of his scientific work. While the public often associated him with simplified explanations of the universe, within the physics community he was respected for rigorous, highly technical contributions. His ability to move between deep theoretical work and popular science writing was rare among scientists. This dual capacity allowed him to influence both academic discourse and public perception, ensuring that important concepts like black hole thermodynamics reached audiences far beyond the confines of research journals and conferences. Throughout his life, Hawking sought to convey the beauty of physics. He compared the elegance of mathematical equations to works of art, emphasizing that both revealed deep truths about reality. For him, the joy of discovery was not only in finding answers but also in framing new questions. This outlook shaped his teaching, writing, and public talks. By sharing his enthusiasm, he invited others to see science not as a dry accumulation of facts but as an ongoing, creative human endeavor. Hawking's celebrity status made him a frequent guest on talk shows, at academic ceremonies, and in cultural events. He met heads of state, royalty, and leading figures from many disciplines, yet he treated these interactions with the same curiosity he brought to scientific discussions. Whether conversing with a fellow physicist or a pop star, he sought to learn something new. His openness to different perspectives reflected his belief that knowledge could be found in unexpected places and that intellectual exchange enriched all participants. His fascination with the unknown extended to extraterrestrial life. Hawking speculated on the likelihood of life existing elsewhere in the universe, warning that any advanced civilizations encountered might pose risks to humanity. While he supported the search for extraterrestrial intelligence, he cautioned against broadcasting our location without careful consideration. These views sparked debate within the scientific community, but they reflected his broader concern for humanity's long-term survival and his habit of examining issues from both scientific and strategic perspectives. Hawking was not immune to criticism. Some scientists felt his public persona overshadowed the collaborative nature of scientific research, while others questioned aspects of his theories. However, such debates were a normal part of scientific progress, and Hawking welcomed them. He understood that strong ideas could withstand scrutiny and that disagreements often led to deeper insights. By engaging with critics respectfully, he modeled intellectual humility and the value of open discourse, reinforcing the idea that science advances through constant questioning. His popular science books collectively sold millions of copies, shaping how the general public understood cosmology. Works like The Universe in a Nutshell, The Grand Design, and Brief Answers to the Big Questions covered topics ranging from the Big Bang to the possibility of time travel. These books balanced accessibility with accuracy, a difficult task in science writing. Hawking believed that making science understandable was not dumbing it down, but rather clarifying its beauty, enabling more people to appreciate and engage with it. In his final book, Brief Answers to the Big Questions, published posthumously in 2018, Hawking addressed pressing issues such as the future of artificial intelligence, space colonization, and the fate of humanity. He expressed confidence in human ingenuity but warned that survival required careful planning and global cooperation. The book was both a scientific summary and a personal reflection, offering readers a distilled version of his worldview. It became a bestseller, serving as a fitting conclusion to his decades-long mission of sharing knowledge. Hawking's influence extended into the design of scientific experiments. While primarily a theorist, he consulted with researchers on projects like gravitational wave detection, offering insights into how results might confirm or challenge existing theories. His interest in experimental verification underscored his respect for the empirical foundation of science. Even though many of his own predictions awaited confirmation, he valued the iterative relationship between theory and observation, recognizing that both were essential to building a coherent understanding of the cosmos. His engagement with the public also took the form of answering personal questions about life and motivation. He advised students to stay curious, avoid wasting time on unproductive worries, and focus on what they could do rather than what they could not. These messages carried particular weight coming from someone who had faced such immense challenges. Hawking's blend of practical advice and philosophical reflection resonated widely, making him a mentor not only to aspiring scientists but to anyone seeking resilience in adversity. Hawking's story became a touchstone in discussions about disability representation. He resisted being portrayed solely as an object of pity or inspiration, preferring to be recognized for his intellectual achievements. His success demonstrated the importance of accessibility in higher education and the workplace. By openly discussing his needs and the tools that enabled his work, he contributed to a broader understanding of inclusion. His visibility helped challenge stereotypes and broadened the perception of what people with disabilities could accomplish. The global nature of Hawking's fame meant that his passing in 2018 was marked by memorials worldwide. Public buildings were illuminated in his honor, scientific institutions held special lectures, and social media was filled with messages celebrating his life. Even people with little prior interest in physics expressed admiration for his perseverance and intellect. This widespread mourning illustrated how Hawking's appeal transcended disciplines and borders, uniting people in appreciation for a life dedicated to expanding humanity's understanding of the universe. In reflecting on his own mortality, Hawking often spoke of living without fear of death. He accepted that life was finite but believed that one's impact could endure through ideas and contributions. This perspective gave urgency to his work and a sense of purpose to his outreach. By sharing this philosophy, Hawking encouraged others to focus on what they could create and discover during their lifetimes, framing existence itself as a rare and valuable opportunity in the vastness of the cosmos. Hawking's enduring popularity continues to inspire new generations to study science. Educational programs, documentaries, and exhibitions dedicated to his life regularly draw large audiences. His writings remain part of recommended reading lists for students of physics and astronomy. The Stephen Hawking Foundation supports research into motor neuron disease and promotes scientific education, carrying forward his dual legacy of intellectual exploration and advocacy for disability rights. Through these efforts, his influence persists, shaping both the scientific community and public attitudes toward science. Hawking's legacy is reinforced through ongoing research inspired by his theories. Physicists continue exploring black hole thermodynamics, quantum gravity, and the interplay between relativity and quantum mechanics. Some of his predictions, such as Hawking radiation, remain unverified but drive experimental ingenuity. Space-based observatories and advanced particle physics experiments may one day confirm or refine his ideas. His work serves as both a foundation and a challenge, pushing scientists to think more deeply about the ultimate nature of space, time, and reality. In classrooms worldwide, Hawking's story is often used to illustrate perseverance and creativity. Teachers highlight not only his scientific achievements but also his ability to adapt to immense personal challenges. His life demonstrates that physical limitations need not constrain intellectual ambition. Students studying physics encounter his theories, while those outside the sciences learn from his determination. By transcending disciplinary boundaries, Hawking has become a universal figure in education, representing the idea that human potential extends far beyond conventional expectations and obstacles. Hawking's collaborations extended into the arts, with artists, musicians, and writers drawing inspiration from his work. His robotic voice became iconic, used in songs and multimedia performances. He participated in art projects that sought to visualize cosmological concepts, blending aesthetics with astrophysics. These ventures reflected his openness to interdisciplinary engagement, believing that science and art could enrich each other. By bridging these worlds, Hawking helped create cultural works that communicated complex scientific ideas in ways that resonated emotionally and intellectually with audiences. Although Hawking rejected the idea of a personal God, his discussions on the origins of the universe often entered philosophical territory. He questioned why there is something rather than nothing and explored whether the laws of physics themselves require explanation. While his conclusions were grounded in scientific reasoning, they stimulated dialogue between scientists, theologians, and philosophers. This intersection of fields made his work a touchstone in debates about meaning, existence, and the scope of human understanding, ensuring its relevance beyond physics. Hawking also played a role in advocating for space exploration as a survival strategy for humanity. He argued that establishing colonies beyond Earth could protect against existential threats, including asteroid impacts, pandemics, and nuclear war. His stance aligned with growing interest in Mars colonization and interstellar travel. By lending his voice to these initiatives, Hawking provided scientific credibility and urgency. His vision inspired investment in space technologies, reinforcing the link between scientific imagination and practical efforts to secure humanity's future. In his later years, Hawking became increasingly vocal about environmental issues. He warned of the dangers posed by climate change, unsustainable resource use, and global inequality. He emphasized that humanity's technological prowess must be matched by moral responsibility. These concerns placed him alongside scientists advocating for urgent action on planetary stewardship. By connecting cosmology with the immediate needs of Earth, Hawking demonstrated that thinking about the universe's grand scale does not preclude caring deeply about the fragile biosphere sustaining life. Hawking's fame inevitably led to portrayals in popular culture. Beyond documentaries, he appeared as a character in novels, cartoons, and even internet memes. While some depictions played for humor, others sought to honor his intellect and wit. These portrayals kept his image in the public eye and introduced younger audiences to his work. Hawking himself enjoyed many of these representations, especially when they captured his mischievous sense of humor, proving that he valued laughter as much as scientific rigor. One of Hawking's strengths was his ability to admit when he was wrong. Notably, he famously conceded losing bets with fellow physicists, including one over whether information could escape black holes. He viewed these losses as part of the scientific process rather than personal defeats. This openness to changing his mind when evidence demanded set an example of intellectual honesty. It also reinforced his belief that science thrives on adaptability, and that progress often comes from revising cherished assumptions in light of new data. Hawking's public lectures often combined humor, history, and high-level physics. He used jokes to relax audiences before guiding them into complex topics like singularities or time travel. This approach made him a skilled communicator, able to hold the attention of both experts and novices. His lectures were translated into multiple languages and delivered across continents, often filling large auditoriums. By bringing abstract concepts to life, Hawking made cosmology not only accessible but also captivating, inspiring people to explore questions they had never previously considered. The announcement of Hawking's death on March 14, 2018, coincidentally Albert Einstein's birthday, sparked a wave of tributes. Fellow scientists reflected on his groundbreaking research, world leaders praised his courage, and ordinary people shared stories of inspiration. His passing was covered extensively in global media, underscoring his status as one of the most recognized scientists of the modern era. The coincidence of the date seemed symbolic, linking two of history's most influential thinkers and reinforcing the sense of Hawking's place in the lineage of scientific giants. Hawking's funeral was held at Great St. Mary's Church in Cambridge, attended by family, friends, colleagues, and dignitaries. Crowds gathered outside to pay their respects, while the bells of the university tolled in his honor. Later, his ashes were interred in Westminster Abbey between the graves of Isaac Newton and Charles Darwin. This placement symbolized his status among the greatest contributors to science. The ceremony celebrated not only his academic achievements but also his enduring influence on human thought and imagination. In the years since his death, Hawking's writings and recorded lectures continue to circulate widely. Advances in artificial intelligence have even allowed the creation of interactive digital versions of his voice, enabling new generations to hear him explain complex topics. These technological memorials preserve his presence in educational and cultural contexts. The persistence of his voice in public discourse serves as a reminder that while individuals pass away, their ideas can maintain an active and evolving role in shaping collective understanding. Educational institutions have established awards and scholarships in Hawking's name, aimed at supporting students in physics, cosmology, and disability studies. These programs reflect his dual legacy as a scientist and an advocate for accessibility. Recipients are encouraged to pursue ambitious research while considering the social impact of their work. By linking scientific excellence with inclusivity, these initiatives ensure that Hawking's values remain embedded in the training of future scholars, fostering both intellectual rigor and empathy in the scientific community. Hawking's life story continues to be adapted into new formats, from stage plays to virtual reality experiences. These projects often highlight the personal dimensions of his journey, his relationships, humor, and resilience, alongside his scientific achievements. By humanizing a figure often seen as larger than life, such portrayals make his story more relatable. They remind audiences that behind the groundbreaking equations and famous voice was a person navigating love, friendship, and the daily challenges of living with a degenerative illness, yet never surrendering his curiosity. Ultimately, Stephen Hawking's impact lies not only in his theories but also in his example of intellectual courage. He demonstrated that limitations, whether physical or situational, need not define the scope of one's contributions. By engaging the public with science, pushing the boundaries of knowledge, and advocating for humanity's future, Hawking embodied the union of curiosity and perseverance. His life encourages others to embrace challenges as opportunities, to ask daring questions, and to pursue understanding of the universe with both rigor and wonder. Stephen Hawking's journey from a curious boy in St. Albans to one of the most celebrated scientists of all time remains a testament to the power of intellect, resilience, and imagination. His work forever altered our understanding of black holes, the origins of the universe, and humanity's place in the cosmos. Beyond equations, he left an enduring message that the human spirit can defy physical limitations, and that our greatest adventure lies in the relentless pursuit of knowledge and wonder.